Right, afternoon again, folks. This is probably going to be one of the last of these YouTube videos. I don't know how you're going to cope without them, but we'll see. So it's about transistor switching circuits. So building on from the previous videos about sensing circuits, building on voltage dividers, building on all of the other stuff above that. Okay. So what we need to learn about today is a device, a component called a transistor. Now, in Nat 5 physics, we're going to look at, there's two different types of transistor. They both do exactly the same job, which is they're like an electronic voltage controlled switch. So an automatic switch that will switch something on when you have a voltage in the circuit above a certain value. Okay, so in this, that's the symbol for it. And you can see on the wee actual alpha board kit, it's got a circle round about it. So that might be part of the symbol, I'm not 100% sure. Probably should have checked that, never mind. So this NPN transistor, it forms part of this circuit. All we've got here is a variable resistor that's altering the voltage of the input to the transistor. Okay, so when I click play, you'll see what will happen, that I'll start increasing the voltage going to the transistor, and you want to watch this LED here. So this LED is like a switch on indicator. It's showing that the transistor is conducting, because just now it's off. We've got 0 volts going into the input of the transistor, so therefore the LED is off. And the purpose of this first video is to find roughly what voltage it takes to switch on this transistor, this NPN transistor. So, right, video not working. There we go, working now. So, yeah, it's giving a wee bit of the game away there. So keep watching. Another more dodgy video work, I suppose. You can see I've increased the voltage, and then if you watch at the same time, when it gets to about 0.7, it doesn't necessarily need to be exactly 0.7, it switches on. And conversely, if it falls below 0.7, it's off. Okay, so basically this NPN transistor, the switch on voltage is about 0.7 of a volt or above, and it switches the transistor on. And in this case, all we're switching on is an LED to indicate that the transistor is switched on. Later on, if we go this far into it, you can see that this transistor can switch on another type of circuit, but we'll leave it at this just now. So what we've got here is a very complicated looking circuit, except it's not really. If you look at the left-hand side of the circuit here, you should recognize this as being a voltage divider circuit. This, in actual fact, is the same circuit that was on the wee circuit board that I was using in the video. Okay, so we've got the variable resistor in the bottom half of the voltage divider, and we've just got an ordinary resistor at the top, and all I'm doing is the voltage across here is the input voltage to, here's your NPN transistor, and we have the LED and the protective resistor for the LED there. So just to kind of simplify the diagram a wee bit, hopefully. So this bit, the red dotted line, is not an electrical connection anywhere at all. It's just to sort of indicate what we're talking about. So this first part of the circuit is the voltage divider, like we've been doing umpteen times. Here we have the input voltage to the transistor. I've just drawn the red dotted circle round about the transistor to indicate that, and then I've got the LED. So we've got a voltage divider where the supply voltage will split up across the variable resistor and the top resistor. And as you saw in the video, when you increase the value of that resistance, then it gets a bigger share of the voltage, and the voltage across the variable resistor will increase until it reaches about 0.7 of a volt, transistor switches on and current will flow through the LED, making it light. Now remember, at this stage, the LED is there just as an on indicator to just show that the transistor is conducting. The other type of transistor you can find in Nat 5 physics is called a Mosfet transistor, and it just works in exactly the same way. Oh, that's a dodgy diagram, never mind. It stands for metal oxide semiconductor field effect transistor, but you will not need to remember that. So it's part of the circuit and it just works in exactly the same way. So we've got the same voltage divider circuit here with a variable resistor at the bottom, and we've got the Mosfet transistor, and the difference between the Mosfet and the NPN is the voltage that switches it on. And for the Mosfet transistor, it's about 2 volts or above that will switch the Mosfet transistor on. In terms of Nat 5 physics, that's all you need to know. NPN switches on when it's about 0.7, Mosfet switches on when it's about 2 volts. That's all the learning outcomes you need to do about that. So again, if I don't have a video of this, but if I did, then all I'd be doing would be increasing the resistance of the variable resistor. That voltage as the input to the MOSFET would increase until it reached about 2 volts. That transistor would switch on and the current would flow through the LED, making it light to indicate that the circuit is operating. Okay, so we've got a video of a light sensing circuit here. So I'll play the video in a wee second and then you'll see, but basically this circuit here is the same as what we have on there. So we've got a variable resistor at the top, we've got an LDR at the bottom, the voltmeter is measuring the voltage of the input to the transistor. There is your transistor, and you've got an LED and its protective resistor there. Okay, so this is going to be a light sensing circuit. So I'll play the video and see if we can talk our way through it. Okay, so just to kind of repeat that, this is your input voltage here, and then we have a voltage divider with the variable resistor in the top half and the LDR in the bottom half, and then we've got a voltmeter, and as I hinted in the previous videos, this voltage across the bottom half of the voltage divider is the crucial one, because this voltage is the voltage that's going to be the input voltage to the transistor. Now you've got base, emitter and collector, and the voltage is between the base and emitter, but that's, you don't need to kind of memorize that or know that too much. You just need to remember that's the input voltage to the transistor. And there we have that wee thing there that I'm just pointing to is the actual transistor itself. So you can see that in this case, you don't need to adjust the variable resistor to make the voltage increase, because if the voltage across the LDR is above 0.7 of a volt, it's actually 0.9 of a volt, you can see the transistor conducts and current will flow from your 0 volts here through the transistor, through the LED up to the plus there. Current is flowing through that. So this transistor acts like a voltage operated switch. It's an automatic electronic switch. So how does this part of the circuit work? Well, you should be able to kind of explain this if you watched the previous videos and understood them. So if we decrease the brightness, so light down, then the resistance of the LDR will increase, and therefore voltage across the LDR increases, gets a bigger share of the voltage. And if it increases above about 0.7 of a volt, because of this transistor, it's actually 0.9, the transistor conducts, and you can see the LED lights in this case. And so this circuit is monitoring low light levels, because when it's bright, if we let the light go back into it, brightness increases, so the resistance of the LDR decreases, voltage across the LDR decreases, it falls below 0.7 of a volt, transistor doesn't conduct, and the LED doesn't light. So this circuit doesn't operate when it's bright. This circuit operates when it's dark. And so hopefully you can figure out that then what this circuit is going to do, instead of just being a wee LED indicator, this circuit, we could control something else, which would be, so it gets dark and it switches on something else. So this could be a circuit that would be used to switch on street lights automatically, for example. So it gets dark enough, and the circuit operates to switch on the street lights. Just a wee quick reminder, circuit switches on when it starts. This is a circuit that's for sensing low light levels. Resistance of the LDR would increase. When it's dark, voltage across the LDR increases until it reaches about 0.7 of a volt. Transistor switches on and the LED lights. Okay. So in this one, what we've done, if you look at the circuit diagram here on the left-hand side, and if you've been watching the videos previously, then what I've done is I've switched the components around. So we've got the LDR in the top half, or the high end of the voltage divider. We've got the variable resistor across the bottom, but the circuit's exactly the same. And so this circuit, hopefully you'll remember that if you flip these components around, the circuit operates in exactly the opposite way. So let's start the video and let's have a look. So LDR at the top, variable resistor at the bottom. And remember, it's the voltage across the bottom component that we're actually monitoring. It's this voltage here. So we're not actually measuring or monitoring the voltage across the LDR. I'm just adjusting it so that the LED's off, so the transistor's not conducting at a certain light level. And that's actually what the variable resistor is used for. It's for controlling at what light level or darkness it would switch on. So what I'm now going to do is I'm going to shine a light on the LDR, and you can see that the voltage here increases above 0.7 of a volt when it gets light, and transistor conducts in the LED lights. So remember, if the voltage across the bottom increases, the transistor conducts. And in this case, it's an NPN transistor, so that switch on voltage is 0.7. So let's go through that again. Shining the light onto the LDR will light up, resistance down. So as brightness increases, the resistance of the LDR will get less. So therefore, the voltage across the LDR will decrease. It gets a smaller share of the supply voltage. And therefore, the voltage across the variable resistor will increase. Remember, that's the input voltage to the transistor. If it's more than 0.7 of a volt, that transistor will conduct in the LED lights, which is what you're seeing in the circuit here. Bear in mind, we haven't adjusted the variable resistor at all. It's just because the resistance of the LDR changes, its voltage share changes, so therefore the share of the voltage across the bottom one also changes. In this case, the variable resistor gets more of a share, and you can see the transistor conducts and the LED lights. So this circuit switches something on when it gets light. In this case, we're just indicating it with the LED, but this circuit is a circuit for sensing high light levels. And I suppose you could figure out that something that would need switched on when it gets light. This is going to be a really stupid example, but it could be if you had a really fancy place where when it gets really bright, it closes curtains. That's a rubbish example, but never mind. So this one, when the component is up the top like this, there's an added bit of the explanation you need to talk about. So the circuit in this case is a high light level sensing circuit. It switches something on when it gets bright. So the resistance, to go through that, resistance of the LDR will decrease when it's bright. The voltage across the LDR will decrease. Therefore, the voltage across the variable resistor will increase. And if it rises above 0.7 of a volt, the transistor will conduct and the LED will light, which is what we've seen. Okay, this one. Now there's some real dodgy camera work in this one. This is a temperature sensing circuit. So now we've got a variable resistor and a thermistor. Remember, that's the symbol for a thermistor. And we've still got our NPN transistor, and we've got our LED, etc. Bit of a giveaway in the video there. It says this circuit is sensing high temperatures. But the important bit that you need to be able to explain how it operates. Okay, so we'll set the video going. Doesn't last very long, this one. Heating the thermistor by putting my fingers round about it. As you'll see, there's some real dodgy camera work. Try to do this one-handed, and I'm not that good. So you can see when I heat the thermistor, you watch the LED, it lights. Put your fingers around the thermistor, transistor switches on when it gets hot. So this circuit is a circuit that is for sensing high temperatures. I'll put that in a loop. So how does it work? That'll be the dogs. The circuit switches on when it's hot because if the resistance of this LDR, that should read thermistor, resistance of the thermistor decreases when it's heated, so the voltage across the thermistor will decrease. So voltage across the variable resistor will increase, and if it reaches 0.7 of a volt or above, then the transistor switches on and the LED lights. So just to make sure that's clear, that should read thermistor. Mistake on my part. Last one is the opposite circuit in terms of we've now got the thermistor on the bottom half of the voltage divider. We have the variable resistor across in the top half of the voltage divider. And this circuit, I don't have a video for this, but basically this is going to be a circuit that is going to operate at low temperatures. This is going to be a low temperature sensing circuit. So basically how it works will be if it gets cold, if the thermistor is cooled, then its resistance will increase. The voltage, therefore, remember it's temperature up, resistance down. So if it's temperature down, it's resistance up. So the resistance of the thermistor will increase, voltage across the thermistor will increase. And remember, in this case, there's no other part to the explanation because that voltage across the thermistor is your input voltage to the transistor. And if the voltage is increasing and it reaches 0.7 of a volt, then this transistor will switch on and the LED lights. So this circuit is for switching on something when it gets cold. So it's a cold temperature sensing circuit. So that's that. Next time I'll maybe, but we'll probably be back in school by this time, but we'll do a kind of super complicated one where instead of it being an LED that indicates that the transistor is conducting, we'll actually put it as part of another part of a circuit which will switch on something else. But that may not happen, just depends on timing. Okay, I'll see you later.